Hi students, welcome to Grade 9 Science Quarter 2. This video lessons is all about chemical bonding. And our learning objectives for this week is to recognize and differentiate the different types of compounds, either ionic or covalent compound. Let's start these lessons with a short activity. Identify the given elements, whether it's metals, metalloids, or non-metals. Okay, Kaotin, do you still remember how to identify the elements? It's either metal, metalloids, or non-metal. If not, just look on your periodic table. All the red colors in your periodic tables are categorized as metals, while the blue colors indicates the non-metal. And the last one is none other than the yellow one, which is the metalloids. Always remember that we have only 7 metalloids in our periodic table, and those are the boron, silicon, germanium, arsenic, antimony, tellurium, and the last one is the fluorium. And take notes, Kaotin, that metalloids are a unique group of elements that share the properties of both metals and non-metals. And now, without further ado, let's start our activity. Let's start with iron. By looking at your periodic table, ions belongs to metals. Next, potassium. Potassium is metal elements. How about mercury? Mercury is a metal elements. Next one, radon. Where do you think radons belong? Radon is a non-metal elements. Okay, last one class. How about the germanium? Where do you think germanium belongs? Germanium is a metalloids. Good job, class! Do you know this man? He is the famous chef called Salt Bay. He's popular because of his way in pouring salt. And now, do you know that table salt is a kind of compounds? When we say compounds, compounds are chemical substances made up of 2 or more elements that are chemically bound together. One good example is the sodium chloride or the table salt. Do you like bonding with your friends, family, and loved ones? Bonding as humans are very important to our physical, social, and emotional state. Moreover, do you know that atoms bond as well? And that is what we call chemical bonding. Chemical bonding is the lasting attractions between atoms, ions, or molecules that enables the formation of chemical compounds. And there are several types of chemical bondings. The first one is the ionic bonding. When we say ionic bonding, it's formed through complete transfer of electrons from one atom to another atom. It exists between metals and non-metals elements. Why do atoms bond? Atoms bond to become stable. When a metal element bonds with a non-metal element, it is ionic bondings, where ions are formed. Ions form after a metal atom transfers its valence electrons to non-metal atom. We have 2 types of ions, the positively charged ions, which is the cation, and the negatively charged ions, which is the anion. When a metal element loses electrons, it becomes positively charged. While the non-metal elements gain electrons, it becomes negatively charged. And now we're going to talk about the valence electrons. When we say valence electrons, they are the outermost electrons in a subshell. These electrons found in the last orbit in our orbital notation. We can identify the valence electrons of any elements by looking in our periodic table. Please take a look at this picture. Take note that the number of the valence electrons is equals to the group number of an element. For example, group number 1, the valence electrons is 1. Group number 2, the valence electrons is 2. Group 3 is 3, 4 is 4, 5 is 5, 6 is 6, 7 is 7, and group 8 is 8. For example elements, we have the beryllium. Beryllium belongs to group 2. So its valence electrons is also 2. Is that clear, class? Then, how does ionic bonding occur? It occurs between metal elements bond with non-metal elements. And now, let's go to some common ionic compounds and their uses. Name sodium chloride, formula NaCl, and its uses: food preparation, manufacture of chlorine and sodium hydroxide. Compound name cobalt chloride, formula CoCl2, uses: known as silica gel which absorbs water. Next one, potassium iodide, formula Ki, iodine supplement in iodized salt. Next example, silver nitrate, formula AgNO3, uses: antiseptic and germicide. Next compound is aluminum chloride, formula AlCl3, uses: use in deodorant. Last example of ionic compounds is potassium nitrate, formula KNO3, uses: used in gunpowder, matches, and fireworks. Now, let's proceed to the boiling point and melting point of the ionic bondings. Ionic compounds, melting points, and boiling point in degree Celsius. Example number 1, calcium oxide, formula CaO. The melting point, 2580 degrees Celsius. Boiling point, 2850 degrees Celsius. Next one, we have the magnesium chloride, formula MgCl2. Melting point, 714 degrees Celsius. Boiling point, 1412 degrees Celsius. Third one, sodium fluoride, formula NaF. Melting point in degrees Celsius, 993. Boiling point in degrees Celsius, 1695. Fourth example, aluminum oxide, formula Al2O3. Melting point in degrees Celsius, 2030. Boiling point in degrees Celsius, 2970. Last example, sodium chloride, formula NaCl, melting point 801 degrees Celsius, boiling point 1400 degrees Celsius. That's all for today, Kaotin. Make sure to watch my next video on how to show the ionic bonding of the latent example of ionic compound. Goodbye, Kaotin. See you on my next video. Mwah!